Hello, today we're going to talk about surface area. One of our first days today, we're going to talk about kind of prism type shapes where they're sort of the same the whole way through. And then tomorrow we'll talk about cones and spheres, which, there's formulas for that as well. And that's mainly what we're going to be using, but I want to talk a little about why that kind of works. Some of this might be a little bit of a review as well, but just to get some of that geometry stuff down, that's what we're going to do the last week here. So here we're going to talk about surface area, which is the area of the surfaces, right? There's not a whole lot to that. Today here we're going to look at rectangular prism, which sounds really complicated, but basically it's just a box. That's it. And then a cylinder as well. So just a couple of examples to show you guys here. Surface area, again, of a rectangular prism essentially has 6 surfaces, 2 copies of each of these 3 types. So like there's 2 yellow surfaces, 2 blue, and 2 green. If you kind of visualize it, the blue is on top and there's a blue one on the bottom, which we wouldn't be able to see. So the more efficient way to do this, there's lots of ways. You can go ahead and do this however you want, but I like to figure out each individual surface, double that because there's 2 of those, and then add those all together. So for example, this blue surface is 10 by 3, right? That's this blue surface here is 10 by 3 because it's 10 this way and then 3 this way. The green surface would be 10 by 4, right? That's what it has here. It's 10 this way and then 4 this way because I can transfer that distance there. The last surface is 3 by 4. And now there are 2 surfaces here, so I have to make sure to double each of these because there's 2 of each of those surfaces. And so then here are kind of my subtotal here. Of the blue ones, it's 10 times 3, which is 30, but there are 2 of those surfaces. So those 2 surfaces together are worth 60, and so on here. Here, this would be 10 times 4 times 2, which is 80, and then here 3 times 4 times 2, which would be 24. And then to get our entire total, what we would do is we would add all of those up, the 60, the 80, and the 24, which is 164. That would be the total surface area. Then we would add up each of these subtotals to get to the end. And that's the whole thing, that we're just adding up each individual surface on there, okay? All right, if we look at a cylinder, a little bit different shape, if we look at a cylinder here, it is essentially comprised of, if we sort of take it apart, right, it's comprised of 2 circles and then 1 rectangle kind of in the middle here, this blue thing. Even though it would wrap around, if you were to sort of take a can and cut it up the middle and pull it open, right, it would make a rectangle. And you can kind of see that too. You can do that with any sort of piece of paper if you wanted to. If I start with a rectangular piece of paper and roll that into a circle, that essentially makes a cylinder. I just don't have the circles on top and bottom, but that's all it is. The outer part of a cylinder is just a rectangle. So really we can use our ideas from rectangles to figure that out. So this surface here, right, is 12 on one side. Yeah, so if I bring this down, this would be the same thing. It's a height of 12 here, and that's that same one. Now this top surface is a little bit different because it is the circumference around here, right? This whole top side, kind of like we did here, this whole top side on this part has to turn into a circle. It's the circumference of that rectangle. Okay? It's the circumference of that rectangle. So in this case, this surface would be 12 times, and I better make this a little bit bigger so we have enough room to write in here. It's 12 times, well, the circumference of that is going to be the diameter times pi, okay? So I do have to be a little bit careful that we are going to have to use the circumference there as well. And if you look it up online, there's probably one big thing there. You could probably find one big giant formula. I'm going to do these in pieces. So here, this is the surface. Okay? That's that rectangle in there. There's only one rectangle this time, though. There's only one of those. There's only one rectangle. And so then we would multiply those together. And I would have to type that into a calculator. That's 120 times pi, okay, which is, if you want to, you can put that into See here, you can put that into decimal form. I'm just going to leave it with the pi after it. 12 times 10, say it's 120 pi. And that's perfectly fine. If you want to leave it in terms of pi, you can. If you want to go all the way to a decimal, you can as well. And then the surface, remember there are these two circles, one on top and there's one on bottom. So I'm going to figure out one of those. Now we have to switch gears a little bit. The area of a circle is pi times the radius squared. So the radius here is actually 5. So I do have to be a little bit careful. It is not 10. So here it's got to be 5 times 5 times pi, and there are 2 of those. So in this case, again, you could multiply all that stuff together. You could put it in decimal form. I'm going to do 5 times 5 times 2, which is 50, and then I'm just going to put the pi afterwards. So when we go to the total here, I can say it's 120 plus 50. That is 170, and then just put the pi afterwards. That's fine. If you want to change that to a decimal and you want to, type in 170 times 3.14, you can as well. But sometimes it's maybe just a little bit easier to leave this pi afterwards. It's perfectly fine if you want to do that in there, okay? So that's it with the surface area of those shapes. If you guys have any questions, go ahead and let me know.